This video has been put together by Blue Haven Pools for our new clients and customers, or anyone who just wants to learn about basic water chemistry. Water balance is the key to having clear, clean water. There are three controllable elements in water balance: pH level, alkalinity level, and calcium hardness. When all three are in the proper range, the pool water is said to be balanced. If one or more are out of range, damage can occur to the pool surface, to the pool equipment, and also cause very poor water conditions. Later on, we will talk about chlorine and stabilizer as well. We're going to talk about total alkalinity first. It is very important. It can be thought of as a buffer for pH. It measures the water's resistance to a change in pH. When you have a large number of bathers, rainwater, or even when you add chlorine, it will raise or lower your pH. To prevent rapid pH changes, make sure your total alkalinity is between the range of 80 to 120, and this will help stabilize the pH level. You're going to use a chart to determine how much product to use. You'll need to know the gallons of the pool water, your current total alkalinity level, and how many points you'll need to raise it to reach a target of 100. You'll use that middle number as your target alkalinity. If the total alkalinity is too high, pH can bounce around and be difficult to adjust, requiring frequent additions of muriatic acid and a lot of frustration. Chlorine also loses its efficiency as a disinfectant. So to avoid chasing your pH, always balance your total alkalinity first. pH is one of the most important factors in pool water balance. It should be tested daily on new, freshly plastered pools, moving to every other day, and then eventually at least once per week for the remainder of the life of the pool. It's a measure of how acidic or alkaline the swimming pool water is. The ideal pH level of a swimming pool water is 7.2 to 7.6. Keeping the pH in this range will protect your equipment from corrosion and protect calcium, keep it from precipitating out and sticking to hard surfaces, causing scale. It can provide a more effective use of chlorine and provide swimmer eye and skin comfort. pH balance is caused by alkalinity that's not in the proper range. If the pH is unstable, you will test it one day, it'll be high, the next low, and then back high again. Those bouncing around values could be due to high or low alkalinity. If the pH level is too low, plaster surfaces of the pool will actually begin to dissolve, creating a rough texture on your plaster. Metals can start to corrode, including expensive swimming pool equipment such as heat exchangers, and pump seals can begin to develop leaks. As the swimming pool walls and metal parts corrode, sulfates are formed, and these sulfates, when dispensed back into the water, can cause unattractive brown and black stains. If the pH level of the water is too high, calcium in the swimming pool water will combine with carbonates, and it will come out of liquid solution, precipitate onto hard surfaces, and form scale. That's also called calcium carbonate scale. Swimming pool water will start to become cloudy and murky and lose its sparkle. The calcium will also clog up your filter elements and reduce effective filtration. Calcium can also plate out onto a salt cell if you have a chlorine generator and cause it not to make chlorine. As the pH rises, also the power of your chlorine reduces. We'll talk about that a little later on. In alkaline swimming pool water, swimmers experience burning of the eyes, nose, skin gets very dry and itchy as well. Calcium hardness is a basic component for most animals, plants, and it's present in almost all source water supplies. Calcium hardness refers to the calcium content of the water. The ideal range for pools is between 200 and 400 parts per million. If the calcium hardness level gets too low, the water becomes aggressive and will actually start leaching or sucking the calcium out of the plaster, causing pitting, chipping, or even chunks of plaster just to fall off in the pool. If the calcium hardness is too high, the water may have a very high tendency to form scale. If it's not possible to fill the water from a lower calcium content source, well water is often very high, sometimes municipal water is lower, then frequent additions of some kind of sequestering agent or scale defense will be required to minimize the chance of unsightly white or gray scale developing all over the plaster. This chart shows us the ideal levels of some key factors to good water chemistry. Let's first look at the pH level. It should be between 7.2 and 7.6. If it's too high, you'll use muriatic acid to lower it, and if it's too low, add pH increaser to raise. Total alkalinity should be between 80 and 120. If it's too high, you will also use muriatic acid to lower. If it's too low, add alkalinity increaser to raise. Calcium hardness should be between 200 and 400 parts per million. If it's too high, you can partially drain some of the water if you're able to refill it from a source that contains less calcium, or add a sequestering agent monthly. If it's too low, add calcium increaser. Look at the free chlorine as well. The ideal level for normal pools with an automatic pool chlorinator is between 1.5 parts per million and 3 parts per million. If your pool is equipped with ozone and/or UV, you can keep your chlorine levels significantly lower, between 0.06 parts per million and 2 parts per million. If it's too high, you can use a chlorine reducer, but typically chlorine will come down on its own. If it's too low, superchlorinate, add shock, or replenish your chlorine tabs. Also look at cyanuric acid. The ideal level is between 30 to 70 parts per million. And we'll talk about this a little later on. Testing your pool water. Test your pool water daily on new constructed pools. It's very, very important to keep your plaster looking beautiful. Move to every other day after about 2 weeks. And after 60 days on a newly plastered pool, if your pH and alkalinity have stabilized, you may move to testing your water as needed. But we recommend at least 1 to 2 times per week for the life of the pool. Remember, scale and problem water can develop very, very quickly, so frequent testing and prevention is key. You may use test strips that are very convenient and effective for basic water balance. You can also use a liquid test kit with reagent drops, and you check the colors against a chart that will give you your proper alkalinity, pH, and chlorine levels. But we do recommend professional water testing at least once a month. Sometimes test kits and test strips can expire and operator error can occur. So we recommend that you double check your readings at least once a month to make sure that they're accurate, and also check for some elements that basic home test kits don't test for, such as stabilizer, metals, and phosphates, which we'll discuss in later presentations. How much product do I add? To determine how much product you'll need to add when adjusting your pH or alkalinity, you'll need to know a couple of things. First, how many gallons of water do you actually have in the pool? You'll need to know your current pH and alkalinity level and your target levels. Calculate how many points you want to change between your current level and target level, either raising or lowering. Use the chart to determine how much product to use. If your gallons fall between values, because a lot of the charts raise in increments of 5,000 gallons, use the lower one. You can always add more if needed. Now, never add large quantities of acid at once. We only recommend between 1 and 1.5 gallons per day, depending on how many gallons you have in the pool. And when using increasers, add only half the desired amount, retest, and then add more if you need it. They tend to spike pretty quickly. On your powdered increasers and decreasers, just follow the instructions on the charts on the back of the containers. If your calcium hardness is too high, or if your pH and alkalinity are out of range and allow calcium in the water to precipitate out, scale will develop. Now, scale is very hard to remove. It's ugly, it's rough, it causes white patches and white flaky scale all over the plaster. It can be above the water line, on the tile as well. So prevention is of the utmost importance. And in order to prevent scale, we recommend using a scale defense or other sequestering agent, such as scale-free. Scale-free will protect your pool from damaging effects of scale buildup and staining, and it also works without adding phosphates to the swimming pool, which is very important. Scale can develop very, very quickly overnight, and it can also develop very slowly over time, over years, and you may not even notice it until it's out of control. For scale defense to work, though, you do have to add it monthly as a maintenance dose and stay on top of it. Here are some charts to assist you in adjusting pH and alkalinity. The top chart is for lowering alkalinity with muriatic acid. To use this chart, figure out your current alkalinity level and subtract 100. That's your target goal. That number of points is how much you'll reduce your alkalinity level by. Find that number on the left-hand column. Follow it over to the appropriate number of gallons in the pool, and that will tell you how much muriatic acid to add to achieve a 100 part per million total alkalinity level. The second chart is for pH. You will find your current pH level, follow that line over to the appropriate number of gallons in the pool, and that will tell you how much muriatic acid to lower your pH to 7.2. Now remember, muriatic acid lowers both alkalinity and pH. So if they're both high, you should only need to add one product, the muriatic acid, and it will lower them both. Retest and see if you need to lower pH any further. If you do, you can use a product called pH Lower. That will lower the pH level and not alkalinity. Now the last two charts are for raising alkalinity and for raising pH. You'll use those in the same fashion. Screenshot this and keep it handy to use when adjusting alkalinity and pH on your pool. Caution, pool chemicals are dangerous, so you need to take extreme caution when handling chemicals. We recommend using protective eyewear and gloves, particularly with muriatic acid. Always pre-mix or dilute chemicals in water. Add chemicals to water that's already in a 5-gallon bucket, never the reverse, because adding water to the chemicals could cause splash out, it could stain your deck, it could splash it on your skin and potentially burn you. Never add chemicals directly to the water. They are heavier than water and they will fall to the bottom and can stain the pool. Muriatic acid is very harsh. It will eat through concrete. Do not breathe the vapors. Don't get it in your eyes, mouth, or skin. Again, wear protective eyewear and gloves. Don't allow children around you when you're handling chemicals. A spill or splash out could cause them harm. Don't store muriatic acid next to chlorine. In fact, and don't store any pool chemicals next to anything flammable. Don't mix chemicals on your deck area. If it spills out, it could stain or discolor your deck. Choose a grassy area to set your bucket in to do your dilution. Grass is a lot less costly to replace if you should spill it. And mix all your chemicals in a 5-gallon bucket full of water, then disperse them evenly into the deep end of the pool and mix it around. If that bucket is too heavy for you to lift, you can use smaller buckets like a 2-pound and just make more batches of diluted chemicals. Now that we've covered pH, alkalinity, and calcium hardness, the 3 major components of water balance, we'll move on to chlorine. Free chlorine is the amount of chlorine in the pool that is available to sanitize or kill bacteria in the water. This is the one you will test for. This is the reading that tells us how much chlorine is ready to get to work killing contaminants in the pool. Combined chlorine is chlorine that's already used up. It's already combined with such things as ammonia, nitrogen, and other contaminants. It's what causes that really foul, bad, strong smelling chlorine smell, and it can also burn your eyes and cause skin irritation. You can get rid of those combined chlorine elements by superchlorinating or shocking the pool. Those are called chloramines. And if combined chlorine is at least 1 part per million higher than free chlorine, we recommend shocking as needed to reduce. If your pool is equipped with an ozonator, it destroys chloramines on its own, reducing your need to shock frequently. Now, total chlorine is the total amount of chlorine in the water. It obviously includes free chlorine and combined chlorine. So when you're testing on your test kit, make sure that you're actually getting a reading for free available chlorine. Chlorine effectiveness depends highly on pH level. Now take a look at the chart at the bottom of this slide. Chlorine is most effective at a pH of 7.2. At that point, it is about 70% effective. If your pH level becomes high, like 8.0 or 8.5, your chlorine effectiveness is only 10 to 20% effective. And basically at that level, you are wasting your money shocking the pool. It's barely working. So always get your pH in the proper range first, make sure the water is balanced, then add chlorine or shock the pool. Now, chlorine can be effective at lower pH levels. For the previous reasons stated, we don't recommend keeping the pH of the pool water any lower because it can cause corrosion to heating elements and cause pump seal leakage and swimmer discomfort. Chlorine considerations to remember. If free chlorine is too high, eye, nose, throat, and skin irritations can develop with swimmers. If free chlorine is too low, you can get algae blooms and bacteria can grow, and waterborne illnesses can thrive, as well as cloudy water. If free chlorine is just right, between 1.5 and 3 parts per million, that should be enough available chlorine to combat future demand, barring any special circumstances, which we'll talk about in advanced chemistry. Now remember, if you have an ozone or UV system, you can keep chlorine as low as 0.06 parts per million, just maintaining that little residual. That's significantly lower chlorine levels. Cyanuric acid, or stabilizer, is another very important element to consider. Cyanuric acid protects chlorine from being degraded by sunlight. The desired level is between 30 and 70 parts per million. Now, on the internet, you may find some different ranges, but this is what Blue Haven finds to work the best in Oklahoma. Higher levels of greater than 100 parts per million can, but not always, inhibit chlorine from working well. So we don't want to get it too high. Yet lower levels won't provide adequate protection from the sun. We've found at least 30 parts per million is required to keep sun from degrading the chlorine. It's easily measured with a test kit or at your pool professional testing station. Don't add too much cyanuric acid to the pool. The problem is it can only be removed from the water by partially draining and refilling with fresh water. So we don't want to overdo it. Also, use of trichlor or dichlor, the tabs, and shock, they contain cyanuric acid or stabilizer as a part of their formula. So they will raise cyanuric acid levels over time. So if you keep it on the lowest level necessary to keep a free chlorine level in the pool, then that will allow for your CYA levels to raise naturally over time without requiring draining of the water. Now you should have a pretty good understanding of basic water chemistry. We've covered the 3 components of water balance, pH, alkalinity, and calcium hardness, and discussed how they all work together. We've also covered free chlorine and stabilizer, which helps chlorine keep from being degraded in sunlight. Please watch our advanced water chemistry videos covering algae and how to remove it, different types of chlorines, metals, total dissolved solids, and the saturation index. Please like our video if you found it helpful, and we ask that you follow our Facebook page for more information and blogs on pool maintenance. If you have any questions, please call Blue Haven Pools of Oklahoma, and our experts will assist you in maintaining a comfortable, clear pool.